This is section 2 question 4, which is your plan for 12 marks. I've done a kind of longer answer version of this, but I thought I'd just do a mind map to try and make it a bit simpler. So we've got our reactivity experiment. So I can put that in the middle, and the things it's asking us for are here. So I'm just going to try and draw these out. So hypothesis, we've got equipment, techniques, standard procedures. So we could possibly break that up. Equipment, then techniques, health and safety. Most students are okay with the health and safety part, and probably spend a bit too much on that, and not as much on the other parts. And data collection. So for example, what's our dependent variable? Is the main one of those. But we're going to have, as part of that really, we're going to have our independent variable. And it actually asks us for controlled variables. And put one down here. This is a bit that wasn't mentioned very well. So data collection. So once you've done that and you've figured out, right, I need to write about all this stuff for these 12 marks, then you have your hypothesis, but it's got to be something to do with this experiment. So if our basic experiment is that we've got a solution of our metal salt, and we are adding some metal to it, and this is the bit that people struggled on. These release thermal energy, so we're measuring this with a thermometer, and if a displacement takes place, then there'll be a temperature rise. So that's where you kind of really start. Our dependent variable is, measure temperature rise. And you could, how much and over what time. That's really what you're doing. Our independent variable is our range of metals against metal salts. So range of metals versus the range of metal salt solutions. And now we can do our hypothesis that more reactive metals will displace more metals from their salts. So our hypothesis, so more reactive metals will give a temperature rise against more salt solutions. So that'll be telling you whether there is a displacement. Equipment, well, if you look at this little diagram, we need a balance, we'll need a thermometer, we might want to stir this with a glass rod, that sort of thing. We could mention the precision, so 0.01 precision, nearest 0.5 degrees precision there. We could mention this container there, that could be, for example, polystyrene to thermally insulate it, could have a lid on. So you can come up with better things with this method, and that's really, in your techniques as well, things like, lid, stirring. And then once we're doing that, we can think about controlled variables. So for example, the mass of metal, we can think of the volume and concentration of the metal salt. So mass of metal, the volume, concentration of metal salt. Those are the main controlled variables. There are some others, but those are the main ones. And then health and safety, I think we're all fine with the health and safety really. You've got chemicals, chemicals in solution, so it could be irritant. We don't know this, but we can suggest it. So our irritants, we are having a heat rise here, so it might be quite a high heat rise. Who knows? So heat. So health and safety, split it into three things. So identify the hazard, and then what could happen, and then our prevention measure. So for example, the metal salt solution is an irritant. What could happen? Irritate your eyes and your skin. Prevention, wear goggles, lab coat, wash off any spills, clear up any spills off the desk, that sort of thing. And so we've got our data collection now. Measuring our temperature rise, we could be more specific with that. Maximum temperature rise in 1 minute. We're going to measure that to the nearest 0.5 degrees. And the last little bit that was largely ignored was our data collection. What exactly are we going to do with that? Well, I would certainly suggest doing repeats, calculate means. How are we going to relate this to our hypothesis? We can suggest that a temperature rise indicates a displacement reaction, and this is this is the nub of the actual experiment. So the metal that gives a temperature rise with the most solutions is higher up the reactivity scale. So the metal with the most temperature rises with the most metal salt solutions is the most reactive, and so on. You could suggest any stats that you would use. So you are comparing the means of these temperature rises, so you could work out standard deviations or do some other statistical test there, looking for overlapping the data. The Mark scheme indicates the relative temperature rises, but I think you're checking for displacement reactions, and the temperature rise isn't that important. So there's a little mind map. There's a fuller run through of all the points, including a blurry 5 minutes, but I can't bother to record that video again. So you need to try and get as many of those 12 marks as possible.